Hi, my name is George Muradin, and today I'm going to be explaining torque for you. So the textbook definition of torque is the tendency of a force to cause or change the rotational motion of a body. This page is blank. I don't know why I'm lying to you. I'm not going to go by a textbook definition here. It's an explanatory video. I'm going to give you a practical definition. Torque basically measures how effective a force is at causing an object to rotate around an axis of rotation, or rotation point. Now, while this video is going to be mostly explaining how torque works in the real world, practical applications and definitions, we do need to talk about math and how it works in that sense. So I have written the equation here, which is tau equals Rf. Now let me explain this. Tau is how we represent torque in mathematics. Let's talk about R though, because it's a little bit more confusing. R is the distance from where the force is being applied to the axis of rotation. Now, the axis of rotation is what this, and let's say in this example, this is like a metal bar, rotates around, so like a hinge point. And if we think of the force being applied here, then this distance from here to here is R. It's just the distance from where it's rotating to where the force is being applied. And obviously the force is how much force is being applied at this point. So while we're talking about math, let's just do a quick example problem of a sort of easy scenario. So let's take that metal bar we had earlier. Let's just say this is a metal bar. Not that much of an artist, but let's say that the distance from here, which is going to be our axis of rotation, to here, which is where the force is going to be applied, is 3 meters. And the force being applied is going to be 100 newtons. So we just take our equation, tau equals Rf, plug in the numbers, 3 meters times 100 newtons, and we get 300 Newton meters, which is what the torque here equals. And these are the units for torque, Newton meters. This process gets a little bit more complicated when, let's say, this torque is being put at an angle to the metal bar, but it's just a variation on this formula based on what angle the force is being applied. An example of torque, I have this very heavy bag full of textbooks, this plastic bag, and if we imagine my arm as having a axis of rotation around my elbow, which my arm can rotate, see, if I put this plastic bag at the axis of rotation, my arm there's not a lot of effective force pushing it down, it's not causing it to rotate. Whereas if I put it at my hand and let it go, I have to strain my arm a lot more in order to get it to not move down. So if I put my arm completely limp, it rotates. Whereas if I have it at my shoulder or at my elbow and put my arm limp, and it doesn't really rotate. And as I move it out, it wants to rotate more. And that's basically how torque works. As it gets farther away from the axis of rotation, it wants to rotate just a little bit more. Something I didn't touch on that I probably should have in my equation was net torque. Net torque is when there's multiple forces of torque on a singular object. Now, to explain this, I'm going to take this ruler and set it about, so there's about equal length on each side. Let me get that in frame. And then I'm going to take this weight and put it on one side. Now you see, this weight, when I put it at the edge, does make it want to rotate around it. But if I take another torque force, the force of my finger, and put it on the other side, at an equivalent force, at an equivalent distance, then the ruler stays still. I'm counteracting this torque with the torque of my finger. This force at this distance is counteracting this force at this distance. And if I put less force, it goes down. And if I put more force on this side, well then, that happens. So torque is something that's used in our everyday life a lot. A lot of products that we use utilize torque in order to make them function. Some examples of this include doors
and seesaws.
And an example that I totally regret putting in my outline, but now I have to do, moving a heavy rock.
Ah! Jesus Christ.
So you see, I have
I have this shovel on this rock. It's hot out here. I have this shovel on this rock. Why did I wear this outfit? And to utilize torque to rotate this, I'm gonna push like down here, and you see how it's moving it a little bit with a bit of force. But if I push over here, you know, where there's more distance from the axis of rotation, same amount of force shifts it a lot. Woo! Thank God that's over. At my job is another place where we use torque, everyday usage of torque. I see all these lane lines that have to put in the pool. We have to put these in, take these out of my job. And the way we do that is we bring them to the other side, bring them to this side, hook them in, and then we tighten them using a wrench, which is a perfect example of torque. So if you see this lane right here, it's all done up on both sides, but it's loose. So I get this wrench around this hinge, and then since I have to rotate this, I use a force at a distance away, and it's much easier and more effective to rotate it like that. So I hope you learned a lot about torque, I guess. It's the final assignment of my high school career, so I hope I did a good job. I love you, Mr. Kendall, and have a great summer.